All right, let's talk about how we add forces. So if I have a positive charge and a negative charge, and we're going to write these down in a variety of different ways. We're going to start with this is going to be 1 nanocoulomb of a positive charge, and this is going to be negative 3 nanocoulombs of a negative charge. And we're going to go ahead and say that we're going to space this at 0.5 meters. And this is totally arbitrary, all right? Totally arbitrary. You know, we've just put two things in here. And now one of the things that we want to do is if they're opposites, we know that this charge is going to be attracted to that one. And this charge is going to be attracted to this one. So we are going to be very specific about our language. We're going to ask, what is the force on this charge? So we're looking at the force on this charge due to this charge. So the first thing that we're going to do is we're going to calculate the magnitude of the force. And we know that that's K, Q1, Q2 divided by R squared, which is going to be my 8.99 times 10 to the 9th Newton meters squared, coulombs squared. We have 1 times 10 to the minus 9 coulombs. I have 3 times 10 to the minus 9 coulombs divided by 0.5 meters squared. I used the minus 9 for a reason, okay? Because this one is going to make my life a lot easier. Because now I'm going to have on top 10 to the minus 9 because these are going to cancel each other out. And I'm going to have my 8.99 times my 1 times my 3 is going to give me 26.97 on top. And I'm going to have my 0.5 squared, gives me 0.25 on the bottom, times 10 to the minus 9. My coulomb squares cancel each other out. My meter squares cancel each other out. And I'm going to get 26.97 divided by 0.25. And I get 107.88 times 10 to the minus 9 newtons. And I can clean that up and put that in my calculator a different way. But I wanted you to see it done this way because this is a whole heck of a lot easier than dealing with my calculator and potentially getting it messed up. Because a lot of times when we deal with these times 10 to the minus 9, depending on how your calculator puts it in, the order of operations in your calculator may mess that up. So be very aware of that and look for that order of magnitude that we're dealing with. And so you can make it a lot, this is a heck of a lot easier to put in my calculator than times 10 to the minus 9. And you can actually do that and clean that up. Now, that's the order of magnitude, okay? That's the order. Remember, forces are vectors. Forces are vectors, so they're going to have direction and magnitude. So if I want to know what force is on this charge, that charge is going to be pulled in that direction with a magnitude of this right here. So this is going to be this charge is going to move to the left because of this charge. So this is one of those things that's a little different than what we're dealing with gravity, because we have to take into account the nature. Now, if that happened to be a positive charge, right? This is if it's a negative charge. If that happened to be a positive charge of 3 nanometers or nanocoulombs, that magnitude is exactly the same, except now this charge is going to want to go that direction. We can also calculate the acceleration. All right, so we're going to calculate the acceleration. Well, first of all, I'm going to need the mass of the charge. All right, we know that 1 electron is equal to 1.602 times 10 to the minus 19 coulombs. I need to know how many electrons I have in 3 nanocoulombs. Okay. So 1 electron is 1.6 times 9, or that negative, because there's my negative. But I need the number of electrons in order to determine the mass. I need the number of electrons. So I've got a -3 n charge. And this is going to be, we're going to go ahead and multiply 10 to the minus 9. And I'm going to take 1 electron is equal to a negative 1.602 times 10 to the minus 19 coulombs. So I'm going to end up with a positive value. I'm going to have times 10 to the 10 on top. Right? Because this becomes a positive. That gives me 10 to the 10. So I'm going to take my 3 divided by 1.602. And I'm going to end up with approximately 1.87 times 10 to the 10th electrons. So I've calculated the number of electrons. So my mass of my electrons is equal to my 9.11 times 10 to the minus 31 kilograms, and that's per electron, times 1.87 times 10 to the 10th electrons. So my mass is going to be 17.06 times 10 to the minus 21 kilograms. And that's minus 21, just so that you can see it, because it kind of ran into that number kind of ran into what's underneath there. So I get 17.06 times 10 to the minus 21 kilograms. So we're wanting to calculate the acceleration. So remember that force is equal to mass times acceleration. So force divided by the mass is going to equal my acceleration. We calculated the force to be 1.788 times 10 to the minus 9 newtons. The mass we calculated to be 17.06 times 10 to the minus 21 kilograms. Remember, a newton is a kilogram meter per second squared. Kilograms will cancel out. I get meters per second squared, so I've done everything correctly. I'm going to end up times 10 to, I got 21. I'm going to end up with a positive 12. I got 107.88 divided by 17.06. And I'm going to get 6.32 times 10 to the 12th meters per second squared is the acceleration of this charge towards that. Because my acceleration is going to be in the same direction as my charge. My acceleration is going to be in the same direction as my charge.